Chapter 6, Section 3 is about the graph translation theorem. So the first thing we want to do is go ahead and look at 3 different equations and see what it looks like. So if we graph these in our calculator, we'll get an idea. You are going to notice that in equation B, you can't type that into your calculator because it's not a y equals. So all we're going to do is move that to the other side by subtracting 4. And example C, we can move that to the other side by adding 3. So go ahead, put those into your calculator, sketch them, and then pause me and then unpause me when you're done. So you should have gotten graphs that looked like these 3, so we can talk about the relationship in comparison to a normal parabola, which always goes through 0, 0. So you should be able to see easily that this first one, graph A, is shifted 2 to the right. The second one is shifted 4 down. And the third one is shifted 3 up and 1 left. Okay, and hopefully you kind of see that by looking at the -2, the -4, the +1, and the +3. Okay, so we have a theorem that's going to tell us exactly what that is instead of just kind of guessing. If we change the x, the plus something is going to move it left, and the minus is going to move it right. So x should move things left and right because it's a horizontal, right, the x-axis, and then the change in the y moves it vertically. A plus number moves it down, and a minus number moves it up. Now that should seem kind of backwards to you, and that's exactly how I tell students to remember it, is it's kind of an opposite day, because usually we would think negatives would be left and down, but today they're positive. And that's because of this graph translation theorem. And it says y minus k equals a, and then x minus h squared. So it's kind of taking the normal y equals kx squared, and then shifting it to the right and up. So that's where you get right and up. Okay, h is always the amount right, and k is the number up. Okay, and there's a minus here, so that kind of makes it opposite. So think of it as what's being subtracted, or you can think of it as being opposite. Okay, and if you're never sure, just go ahead and graph it in your graphing calculator to check. So let's try a few. So example A says, take this parabola, y equals -5x squared, and shift it 2 to the right and 3 down. So kind of where I start on all these is I'm going to have y minus something equals, and then I've got my -5, and then in parentheses x minus something squared. So this is your general formula, okay, if we're going to shift it. Okay, so y minus something, x minus something, because that's what this formula that we just wrote down said. Okay, so x changes things horizontally, so it says 2 to the right, so I'm going to go ahead and put in a 2, and 3 down would be a -3, so that turns it into a +3. So it kind of makes sense when we talked about a plus number being down and a negative number being right, or you can just kind of plug in the numbers. So I would plug in 2 for going right and a -3 going down, which would make it a negative. Either way, you need a y plus 3 and an x minus 2. So let's try example B. Find the equation of y equals 3x squared under the transformation t -2, 4. So the translation here really is giving me h and k. Okay, so you just kind of put it in order. So y minus something equals 3, and then x minus something squared. So your number out front comes from the equation, and then you just fill in the blank. Well, h is the first number, so it goes with the x. So I fill in a -2, and then I fill in a 4 with the y. So the -2 becomes a +2. So when it gives you the h and the k, you just plug them right into your formula there. Okay, so letter C says, write the translation that changes y equals 1/9 x squared to y plus 6 equals 1/9 x minus 1. So now we just have to write the t. Well, over here I have x minus 1, and instead of x minus h, that would just give me a 1. And then over here, it's usually a minus in the formula, so a plus meant it was a -6. So our translation was t 1, -6. Okay, so let's try example D. Y equals 1/4 x squared, translating 5 units to the left. So I'll go y minus something equals 1/4 x minus something squared. Okay, so set yourself up and then plug in your information. 5 units left. Well, left is a negative, so I'll plug in a -5, which really makes that a +5. And it didn't say I'm shifting it up or down, so I'll plug in a 0. Okay, that could also just be written as y equals 1/4 x plus 5 squared. You don't have to have the plus or minus 0 on the left side. If it kind of helps you to keep things in mind, then maybe you want to plug it there. So if we're thinking about plugging it 5 units left, what is my vertex? Well, 5 units left would be a -5, and I never moved it up or down, so then I would have my vertex at -5, 0. Okay. In example E, they're giving me y equals -2/7 x squared, translating it 3 units down. Okay, so again, I'll just start with my normal y minus something equals -2/7 x minus something squared. So 3 units down. Well, down would change my y value, and down is negative, so I'd plug in a -3 here. It didn't tell me right or left, which would go with the x, so I'll plug in a 0. So I have y plus 0 equals -2/7 x squared, because I have x minus 0. Okay, these two formulas are the exact same thing. Okay, it kind of just depends on which way you like to see it, and you're also going to have to be able to read it in both ways. So my vertex is usually at 0, 0, but I didn't move it right or left, so that's still at 0. But I moved it 3 units down, so 0, -3. Okay, I can also just look at the formula and just tell me what the vertex is instead of always maybe thinking about it. It's always going to be the h and then the k. Okay, so your vertex is the h and the k. The axis of symmetry we haven't talked about, but when we graph it, we're going to want to note that the axis of symmetry is a vertical line, so it's x equals, and it's always the same as the first number in your vertex. So now we'll kind of take a look at some of those, like example F. They give us y minus 3 equals 7, and then x plus 2 squared. So I want to know the vertex and the axis of symmetry. So my vertex is hk. H is what's being subtracted from my x. So what's being subtracted there is a -2, because this could also be written as x minus a -2. And then what's being subtracted from my y is a 3. So that's kind of where that opposite day comes in. It says +2, but what's being subtracted is then -2. You kind of always want to keep in mind that general formula we wrote down in the beginning, and that kind of helps you figure it out. Axis of symmetry we wrote down as x equals, and it's whatever this x coordinate is, so -2. So our vertex is at -2, 3, and our axis of symmetry is -2. So that kind of helps us when we want to graph it like we are in example G. So right now we've got y equals 3, and then x minus 1 squared minus 4. This formula is not the same as f, so I'm going to make it look like f because that looks like our standard form. So I can move my 4 over here by adding it, and then that looks like our general formula that we wrote down in the very, very beginning. So now I've got y plus 4 equals 3, x minus 1 squared. So now it's pretty easy for me to see that my vertex is 1, -4. Okay, so you look at the x, it was x minus 1, so there's my 1. Y minus a -4 is the same thing as a plus, so that's where I get my -4. My axis of symmetry then is x equals, and my x coordinate is 1, so 1. So I've got a point at 1, -4, and I have an axis of symmetry at x equals 1. The axis of symmetry you're going to graph as a dashed vertical line. Okay, it's not actually part of the graph, but it tells us where it's symmetric to. Now to graph it, you're just going to need to find one other point. Okay, so I usually make an xy table, and I say, okay, if my vertex here is at an x coordinate of 1, let's try plugging in 2. So if I plug in 2 to my equation, I get 2 minus 1 is 1, 1 squared is 1, times 3 is 3, and then subtract my 4 will be a -1. So I'd have the point 2, -1. Again, all I did is plug it into this original equation. Well, axis of symmetry means that if I have a point over here, it's going to reflect it to the exact opposite side on the other line. So that makes 3 points, and 3 points means I can draw my parabola. So I'll be looking for 3 points when you graph it, 1 for the vertex, and then 1 for 1 point, and then that you reflected it across the axis of symmetry as well. So let's try that one more time. Let's graph h. Y equals 1/2 and then x minus 5 squared. So let's look at the vertex. So 5 is being subtracted from x. Nothing is being subtracted from y, so that's a 0. My axis of symmetry is x equals, and it's always that x coordinate, so x equals 5. So I'll go ahead and plot that. 1, 2, 3, 4, 5. So 5, 0. Axis of symmetry you have to draw in as a dashed vertical line. And then I'll go ahead and find another point on that line. So if my vertex is at 5, 0, maybe I'll try 6. Okay, so 6 minus 5 is 1. 1 squared is 1 times a half is a half. So now I know that 6, a half is a point, and that will be reflected over here to 4 1/2. So this is a wide parabola over there. Probably not the best looking one you've ever seen, but a wide parabola nonetheless. Okay, so if you're never sure, okay, go ahead and kind of graph in your calculator, and then it'll help you talk about which way you're shifting these parabolas. Okay, so that's the end of my notes. Stop, think, write down what questions you still have. I'm sure you have a lot today, so go ahead, write those down, and we'll talk about them tomorrow.